So here we are, still in outer space with our little space ball and its thrust markers coming out the back like very simplified rocket engines. And we're well on our way to really starting to model some proper physics here. But we have an architectural issue with our code. And you can kind of see we do from just the state of this inspector. It's kind of a mess, right? So this is the time to sit back and start talking about physics engine architecture. What are we going to do in this video? We're going to tell you what we're trying to achieve. In essence, we're trying to achieve this. Look at the screenshot of the inspector on the right. We're heading towards a much simpler system where the physics engine is only responsible for displaying things and including the trails, and then separate forces, whether they be rocket forces or air drags or whatever they are, come in as separate components like that. So that's what we're heading towards. Why is it important to get this right? Well, there's no such thing as right and wrong. There are only actions and consequences. But the consequences of continuing to code it exactly as we are now is that we're going to lose track. So we're going to reorganize our list iteration so that we can deal with variable forces. If you look at the code as it is at the moment, pop over to scripts and then physics engine, you'll see that this force list is at the top. It's an instance variable and it kind of assumes these forces are always there. What we want to do is be clearing this list every fixed update and letting other components feed forces in. So we're going to be doing that. Or you're going to be doing that, and also going to bring the drawtrails.cs right into the physics engine for now. And we're going to move our forces out into separate components. So what do I want you to do? Guess what? It's another challenge video. In case you haven't noticed, these videos with the green outline are for you to do. I really, really want you to pause the video and have your best shot at getting it done. Hopefully you succeed. If you don't, it doesn't matter because I'm always going to show you the solution. But please pause the video and have a go. So what I'd like you to do, once I finish talking you through the code a little bit, is refactor it. So before we do that, let's just go into the code and see where the problems are. Summing the forces, probably a better name than add forces. Let's change that now. Here's a hint for you. Right-click on something and say refactor rename, or just splodge R on a Mac, Control R on a PC, and let's call it sum forces. And then add forces becomes sum forces. That's clearer. Let me show you another example of the refactoring. Why do we in update velocity, why do we leave this line out, the update position? Why don't we just take the update position line, stick it into update velocity, and then refactor update velocity to being update position all in one go? How do you do that? Again, you can refactor and update position. Perfect. All right, so that's an example of starting to tidy things up. What I'm going to want you to do in the sum forces, I'm going to want you to clear the force vector list down the bottom here every time, and I want you to get the forces from another method. So you're going to have to make a public method here called add force. Public, it's going to return nothing, but it's going to be add force like this, and the signature is it's going to take in a vector3 force vector, and it's going to add it to the list when that comes in from another method. You'll know that you've got it right because your inspector will end up looking like this. So you move drawforces.cs into physics engine. That means you need to rip drawforces.cs apart a little bit, put all that's necessary in physics engine at the bottom, make that work, put a show trails checkbox, which is just bool show trails equals true by default, and then you'll be able to turn the trails off right on and off right in the physics engine there. Create an apply force script that simply exposes a force vector and then calls on the physics engine to add that force to the list by using the add force. Not sum forces, we've renamed sum forces so that it's clear that what the difference between adding a force to the list and summing forces, as in going through the list and adding them together, creating the sum of them. And then try applying forces from the script, and what you should have is that you can get exactly the same behavior with your yellow trails showing when you change the forces in the attached scripts. Enjoy the challenge and see if you can get it working with separate components. Okay, so welcome back. Let's take a look at getting this working. I think what I want to do first is move the trails in so that we can continuously check to see that things still work. So this draw forces, I'm going to call draw trails. Why don't we just take all of the code and for now drop it in the bottom of physics engine. Let's have a look. So what I'm going to do at the bottom here is I'm going to say code for drawing trails. Okay, so public bool show trails. Can we define that at the bottom here? Yes, we can. That's absolutely fine to define it at the bottom of the physics engine. That's fine. Force vector 3 list. We don't need that. We have a force vector list. up at the top. So we don't need that. We will need to define a line renderer and a number of forces that it's going to need internally. So that's absolutely fine. I think I'm going to do 3 forward slashes at the top here because that gives you a nice summary. Code for drawing force or thrust trails like that. Okay, fantastic. So on start now, this stuff here is not start. We already have a start, or we may have a start at the top. I like to keep my main start at the top, so I'm just going to rename this method to set up force trails, or thrust trails, should we call them? Thrust trails. We don't need to go and get the component, the force vector list, because we already have it. Okay, we do need to add a component line renderer. We need to find the sprite. We need to set the color, set the width, and set the world space. Great. So we need to set up thrust trails at the top if show trails is true. So we go. Actually, we should probably set it up anyway because how about if you enable it once the game is running? So on start, we set up the thrust trails and then this code gets called. Fine. And then an update. Well, again, we don't want an update. What we want to do is render trails. Okay. So just call that render trails, and render trails says if show trails. That's fine. We can leave that all in here. So what I want to do in my update loop, my fixed update loop, is we sum the forces, we render trails, and then we update the position. Okay, let's try seeing if it works. So we go into the ball. We're going to remove our draw forces script because we just don't need it there anymore. We have a show trails on there. Let's click play. And we have a trail. Let's add another force vector to our list. Let's say we've got 2, and let's make that, I don't know, orthogonal to it and half the size. Perfect. So our forces are now drawing. They're drawing within the physics engine, and we can turn trails off here. And you'll see that the code is set to turn the line renderer off. So hopefully that was clear enough. We can now ditch our draw forces script altogether. It just does not exist anymore. And we have done the first part of the challenge, which is we have the forces drawing inside the physics engine, getting away from any execution orders. By the way, you can make your right panel a little wider. Mine's narrow because of my screen size for recording, but if you get to a certain size, then suddenly you'll see a snap in these force vectors, net force vectors. They'll suddenly all appear on one line. I think that's neater. So the next thing we need to attack is this force vector list. That's really, really ugly, right? So we have quite a nice overall pattern. We have all the stuff to do with drawing trails at the bottom here, including the public exposure of the show trails. So that's fine. Now at the top here, we have a bit of an issue. The issue I have with it is that we are, as I said before, assuming a kind of permanent force, and we don't want that. So what I want to do is start to just have a bit of a refactor here. So what I want to do here is have a new method called add force that we drew the signature for before, and it simply adds a force to the force vector list. So force vector list.add, then the force vector we pass in. Fine. So now we have a public method that other things can call that add things to the list. So that's good news. That's simple enough. We still have the same general pattern. We sum the forces, we render the trails, and then we update the position. So let's take a closer look at some forces. At the moment, it's saying the net force vector for this fixed update is 0, starts afresh. Then it iterates through the force vector list, adding each one of them to the net force vector. Okay, that's all very well. What we need to be doing now is clearing this force vector list every fixed update. Because we want to start afresh, we don't know what components will have pushed new items into the list. So we just go new list of vector 3s. In fact, it suggested it for me there. And of course, that's a method. And if you want to comment, it's clear the list. Okay, so we're now clearing the list every single time. Let's just see what behavior we're getting right now. Well, because we're clearing the list, whatever I do to this, it immediately reverts back. Okay, that's absolutely fine. I actually don't want to see the force vector list in the inspector anymore. I'm going to make it private. And what I tend to do is when things are private, I just separate them out from the public exposures with a new line like that. So finally, how are we going to push a force into this list? Well, I said we were going to make a new method called add force. Let's go ahead and do that and add it to the ball. Add force, there it is. Now I'm just going to tidy it into the scripts directory. Perfect, and I'm going to open it. Now, this is the bit where we need to find ourselves a physics engine. How do we do it? Well, privately, we need a physics engine, and we're just going to call it physics engine. Fine, so that's a private instance variable of type physics engine. What do we do on start? Well, we say physics engine, let's go find it, equals get component of type physics engine. Like that, with a capital P, because it's a type, not an instance. Fine, and it's a method, and a semicolon. Now, before we move any further, this is all very well, but if you look back in the inspector, we want to make sure that if add force requires a physics engine, why don't we use this great annotation we have in Unity to say so? Require component type of physics engine. So now, every time if you ever add force, you require a physics engine to do it. Great. Let's take the update away. We don't care about the update. But what we do want to do is on every fixed update, we simply want to do this. Physics engine. Now we want the small version of physics engine. I'm going to copy and paste it as my type ahead is determined to try and mess me up. Dot add force. New. Well, why don't we expose it in the inspector rather than being explicit? So let's have a public force here, as we said we would. Public vector 3 force vector. Oops. Okay, and then we just add in the force vector. Whew. So, it's a very lightweight component. We're actually going to change this. We're going to use this as a kind of template for serious things like rocket engines and drag forces and all sorts of other stuff. But hopefully you get the idea. This dude has a vector 3 exposed over here. So if we look at add force, when it wakes up, you can put in a force vector, which later will be calculated from more interesting parameters. You also have a private physics engine in here, which we're going to need to connect. That's about connecting the two components together. That's so that this component, the force, can see the physics engine. We then go find it on start once. Sure, it's slow, but it only happens once. And then on fixed update, we add a force using a method into the physics engine, this add force. Let's see what happens. We need to be running for this to work. If we add a force vector of 1, or say 10, well, it seems to be doing the right thing to the velocity. That's great. If I give some velocity of 1 in y, then look, every 1 second we get 1 unit of increase in y. Everything's working except for the trails. I can collapse the trails down, but you can see that whatever I'm doing here, the trails are not working. So the final thing to do is look back at our code and say, well, why aren't the trails working? Okay, so if you look at the sum forces method, you'll find that at the end of it, it actually clears the list. So this isn't a brilliant method name, because it's doing more than it seems like it's doing. So actually what we want to be doing is rendering the trails first and then summing the forces. But summing the forces we need to rename to be sum forces and clear list. Let's just refactor that again so that all of this code to doing the sum forces goes into the update position method. So sum the forces and clear the list. That's what we do there. And then we resolve, or we calculate, position change due to net force. Okay, so we could do that. And then we don't need sum forces and clear list, which is a horrible method name. And we just render trails and then update position. How's that? Much simpler, I think. Fine, so let's test the code. Let's add a force, 10 in the x direction. There's the arrow. There's the increasing x velocity. Let's add another component, which is an existing script called add force. Let's add a 5 in the y direction. There he goes. Perfect. So we have achieved the exact separation that we were looking for. If we move the component up here and then go back to our slide, if you compare what we've got here with the mass, velocity vector, net force, trails and two forces, then that is exactly what we have here. Perfect. So we've achieved separation. I'm going to leave on the screen the core of the code in question. So the core really is just that. Everything else is to do with trails and fluff. And if you want the code for this section, what I'm going to do is I'm going to include a complete snapshot of my project at this stage for you, attached to the very next lecture, so that you can just bring yourself to this stage if the refactoring was too much to follow. But what we've done is we've shown you the process and the thinking process as you go, kind of starting from the inside, starting from things working, making sure they continue to work as you go, and then ending up with a much cleaner solution that still works and is much easier to read. So congratulations on getting this far. Next, we're going to have a little break into dimensions and SI units, and then we're going to build a rocket engine.